Welcome to the deep dive. Today, we're putting on our hard hats, I guess you could say. We're stepping right into the really cutting edge stuff in high performance desktop computing.
Mhm.
We are zeroing in on the new AMD Ryzen 995E X3D processor. This chip is really making waves.
It really is. And our sources today, they're basically a collection of launch reviews, some technical deep dives, all looking at how this silicon monster actually performs out in the wild.
Right.
So our mission really is to pull out the core insights. What's the innovation here? What's the value, for serious users, enthusiasts? Is the hype real?
And just looking at the spec sheet, I mean, even before we get into the fancy tech, it screams extreme.
Oh, absolutely. The numbers alone are immediate signal flags.
Yeah.
But what's fascinating here, I think, is that the specs don't just promise speed. They sort of signal a bigger architectural shift.
How so?
Well, you've got the 16 cores, 32 threads, pretty standard for high-end these days. Okay.
Right.
But then you hit that cache number, 144 megabytes.
Which is
It's massive. It tells you this chip is engineered specifically to crush memory bottlenecks. The performance isn't just theoretical. It's showing up in, well, pretty much every demanding task. The reviews threw at it.
Okay, let's unpack that then. Because that cache number, it's tied directly to this 3D V-cache technology AMD keeps talking about. That seems to be the star feature. But what does it actually mean for the listener beyond just more cache?
Yeah, it's definitely the defining feature.
Yep.
And the concept is, well, it's physically quite demanding, actually. Instead of just making the cache footprint bigger on the main silicon die, they're physically stacking extra cache right on top of the existing L3 cache.
Stacking it.
Stacking it, using a technique that allows for this really dense vertical integration.
Okay, but why? Why stack it? Why not just, make the chip bigger like they used to? Lay it out flat.
It really boils down to physics and latency. Think of it like this. When a core needs data, getting it from your main system RAM, your DDR5, that's like fetching a file from across the room. Takes time, right? The standard L3 cache is like having that file on your desk.
Yeah.
Closer, faster. But this 3D V cache, because it's literally stacked right on top, the path the data travels is dramatically shorter.
Ah, okay. Physical proximity.
Exactly.
Yeah.
It cuts down that delay the latency to almost nothing. So yeah, the huge capacity is impressive, but that latency reduction is the secret sauce for performance.
That makes a lot of sense. The memory access is practically instant. And the sources are saying this translates directly into, well, noticeable benefits, not just small speed bumps.
Precisely. The word noticeable comes up again and again, especially in anything sensitive to latency, so competitive gaming, for instance. The 3DD cache helps frame time consistency and those minimum frame rates way more than just raw clock speed can.
Sure.
And complex workloads that are constantly shuffling data around, compiling huge amounts of code, or some machine learning tasks they run with this remarkable fluidity, as one review put it.
Because the cache acts like a giant buffer.
Exactly. A massive, super fast buffer. It handles the data demands before the CPU even thinks about slowing down to wait for the slower system memory.
And the sources mention specific games, right? Especially with large data sets or running multiple heavy apps at once.
Yeah, some reviewers literally called it the cache king. And for good reason.
Right.
And the key thing is, it's not just for niche, super specific tasks. Even in just heavy day-to-day multitasking, you see less stutter, more responsiveness, because the processor just isn't waiting for data as much.
Okay, so the cache is a huge part of the story. But moving beyond that innovation, we still have the raw power foundation. Those cores, 16 cores and 32 threads. That's still the muscle, isn't it?
Oh, absolutely. That configuration is, well, essential for serious productivity today.
Right.
If you're someone who's maybe streaming high-quality gameplay while simultaneously editing video or rendering complex 3D stuff, software loves those threads. The processor just handles it all without breaking a sweat, according to the reviews.
But hang on, let's push back slightly. For enthusiasts, especially gamers, we know many games still lean heavily on single-thread speed, right? They don't always use all 16 cores effectively. So is that huge core count mainly just like future-proofing, or is there real value now for someone who isn't rendering 24/7?
That's a really critical point, and you're right. For just gaming, 16 cores is largely looking ahead. But it delivers value now in a couple of key ways. First, like you hinted, it lets all those background tasks, game capture, Discord, whatever, run completely separate from the main game threads. No interference.
Okay, smoother gaming experience overall.
Right. And second, for the professional, the creator, That core count is immediate time savings.
Hmm.
Rendered times drop, sometimes dramatically. That's pure productivity gain right there.
So it's kind of the best of both worlds then. Big core counts for heavy lifting, but you still need the clock speed for those other tasks.
Precisely. And that's why the boost frequency is also highlighted up to 5.7 gigahertz. That's really high. That ensures you get that snappy single-thread performance for games, or maybe older professional apps that aren't fully multi-threaded yet.
So you need both, the high clocks and the cores.
It's the combination, the synergy. Use the 5.7 gigahertz burst for the speed-sensitive stuff, and let the 16 cores chew through everything else.
Got it. And all this speed and power, it generates heat. The sources mention the TDP, the thermal design power, 170 watts. For listeners maybe not tracking wattage numbers, what does that 170 W practically mean for cooling? And what does it tell us about the chip's potential?
Right, 170 W. It tells us two main things. First, AMD is giving this chip enough power headroom to really stretch its legs. It means it's less likely to throttle back its speed when you're pushing it hard for a long time. It can sustain higher speeds for longer.
Okay, sustained performance.
Exactly. But second, and this is crucial, it means you absolutely need good cooling. 170W isn't crazy high for a flagship chip today, but it demands at least a very high-end air cooler, preferably, really, a decent AIO, an all-in-one liquid cooler to keep those frequencies optimal and ensure stability under heavy load.
So yeah, that sustained responsiveness is great, but it comes with a mandatory investment in cooling.
Absolutely. You can't skimp here. If you buy this processor and put a basic cooler on it, you're leaving performance untapped. You have to budget for proper cooling.
Makes sense. And all that power needs a solid foundation, right?
Yeah.
Which brings us to the platform AM5, longevity, future-proofing.
Yeah. The 9950X3D slots into the AM5 socket platform, which is robust. Now, yes, if you're upgrading from an older AMD system, you will need a new motherboard. That's an added cost, no doubt.
Right.
But the upside is that AM5 was designed specifically for these more powerful, demanding chips.
Yeah.
Better power delivery, better features overall.
And what's interesting there is the support for modern standards. That seems key for longevity. We're talking DDR5 memory, PCIe 5.0.
Yes. And PCIe 5.0 especially is kind of the unsung hero here. It's not just a number on a box. It means you avoid bottlenecks when you plug in the absolute latest, fastest NVMe SSDs. We're seeing Gen 5 drives now that are just incredibly fast.
Double or triple the speed of older ones.
Easily. And if you've invested in one of those super fast drives, PCIe 5.0 on the CPU and motherboard guarantees you actually get those speeds. No joking the data flow.
That's a really important point. You don't want one expensive part holding back another.
Yeah.
How critical is DDR5 memory in this equation? Does it work hand in hand with that big 3D V cache?
Oh, they definitely complement each other. Think of it this way. The huge V cache handles the immediate, ultra-low latency data needs right there on the chip. But when the CPU does need to go out to the main system memory pool, the higher bandwidth of DDR5 ensures that trip is as fast as possible.
So it minimizes the penalty for a cache miss.
Exactly. Compared to older DDR4 systems, it just makes the whole memory system faster and more responsive from the cache right out to the RAM sticks. It's a holistic upgrade.
So for you, the listener, investing in this kind of premium CPU, the idea is the whole system stays relevant longer. It can handle next-gen GPUs, next-gen storage, without hitting those internal speed limits.
That's the promise of AM5. It secures your investment not just for today, but likely for the next, 3, 4, maybe 5 years of upgrades.
Okay, let's bring it back to brass tacks, practical implications. How does this actually translate in performance for those two big groups, gamers and creators?
Right. For gamers, the reviews consistently show real, measurable benefits. Smoother frame rates, definitely, but maybe more importantly, significantly less stuttering, especially in games known to be CPU heavy or constantly fetching data.
Like simulators or big open world games.
Yeah, exactly. One reviewer specifically mentioned how the 3D V-cache really smoothed out the 1% lows, those sudden frame rate dips that feel really jarring.
Okay, that's a tangible benefit. And for the content creators, the professionals working under heavy load all day.
They benefit massively from the combination. The core count, the cache, it all adds up. It translates directly into faster render times, quicker exports, just more work getting done faster. If a render took, say, 30 minutes on an older high-end chip, the sources show this cutting that down significantly. That's real time saved. Less waiting.
Right. So pulling all this together, the fancy cache, the 16 cores, the fast clocks, the modern platform, the 9950X3D, is clearly targeting the absolute top tier of desktop users.
No question. And the main takeaway, I think, is that this combination really does make it a versatile powerhouse, as the reviews often call it. It's not just a gaming chip or just a workstation chip. It seems to genuinely excel across the board.
Which brings us, inevitably, to the final piece. Cost. The investment. The sources are pretty clear. This thing commands a premium price. Is the performance uplift from the 3D V-cache and all those cores really compelling enough to justify that premium over, say, slightly less expensive high-end options?
Yeah, that's the million-dollar question, isn't it?
It is.
It is expensive. But the argument and the consensus in the reviews seems to be that the performance gains also buy you longevity.
Future-proofing again.
Exactly.
Mm-hmm.
For someone building a top-tier system today, the 9950X3D arguably offers enough performance headroom to delay your next major upgrade for longer. So the value isn't just the speed now, but the fact you might skip a whole generation of upgrades later. You're buying performance for years to come.
Okay, that wraps up our deep dive on the AMD Ryzen 9950X 3D. It really does seem to blend that innovative architecture with just raw processing power. A very compelling piece of tech.
Absolutely. And as we finish, maybe a final thought for you, the listener. The real innovation here might not just be this specific chip, but the whole method, the physical stacking of the 3D V-cache.
Mm-hmm.
It raises a really interesting question about the future, given how well this vertical stacking works for reducing latency and boosting performance. Is this 3D integration going to become the standard way we build all high-performance chips going forward?
Or will it stay a niche premium thing?
Exactly. Will it define high performance across the board, or remain just for the enthusiast market willing to pay that premium? Something to think about as hardware keeps evolving.